Welcome to a short presentation on ScanCAD International's system called ScanSTENCIL, a system designed for automatic optical inspection of stencils and emulsion screens. As you will learn, ScanCAD is the global leader for stencil and screen, as well as PCB inspection, measurement, and data creation. It really is based in the name, ScanCAD. We will have a couple slides about the company itself, a company overview, and we will spend some time on inspection and measurement, just at a high level, before diving into the technology itself, the hardware, process control, and data creation aspects of these systems. By the end, it'll be very obvious why these systems can make a big difference for your organization. As far as the company overview, I just wanted to share with you that ScanCAD has over 1,000 customers installed in 50 countries. These even date back to before ScanCAD was formed. Many of these customers have multiple systems, some as many as 20 or 30 of these inspection systems. ScanCAD has locations in the US and Europe. However, we do have a complete global network of distributors and sales representatives with local support in every corner of the world. All of our systems are PC-based, low cost, easy to use. Most of them are general purpose in nature, and especially with the ScanSTENCIL system you're about to see, that is the case. Finally, we wanted to share that most of our systems are sold in the electronics industry. Some are sold outside, other industries, aerospace, medical, automotive, etc. But again, mostly electronics industry. We do a variety of OEM partners over the years, including Siemens, Panasonic, DEC, Universal, and many others that have packaged this inspection technology in with their equipment. Now we move into inspection and measurement. I just wanted to share with you that our focus here is checking 100% of the part, wanting to make sure that no bad parts are shipped or no bad stencils or screens are used in manufacturing. The objective here is to catch any of these things before you create, rework, or scrap. Our focus is on pass or fail, indicating to the operator when there's a problem. Again, low cost, easy to use programs. And as you'll see in a second, we can inspect millions of features in minutes. Very different than a traditional measurement system where you are only looking at 4 or 5 points on a stencil or screen. This is checking 100% of the part. As mentioned, it's a multi-purpose system, so it can do a variety of other inspections as well as create data. Of course, it does have measurement capability built into it, and those will be some of the things I'll be showing you today. Now, talking about inspection, 100% of the part, just giving you some examples here. On the left, we have a wafer bump stencil, over 350,000 apertures, 4 mil in diameter or 100 micron, and you can see where the apertures are blocked. And I'll actually show this to you in a second. On the right, showing the multi-purpose nature of the system, the same system that will inspect a stencil can also be used to inspect actual solder paste or printed or dispensed adhesive on a PCB or on a board. Not only is it used in FR4, traditional FR4 type applications, substrates and PCBs, but as well as the alumina, hybrid, or LTCC type applications. Let's go ahead now and just take a brief look at the software itself so you can see what the software looks like, and also let's go ahead and inspect the stencil. In this case, we are looking at the main menu of the system. On the left-hand side, you can see where we can look at creating new jobs that are coming in, looking at an active job and the information related to the job. In this case, I'll just go ahead and open up the job. In this case, a wafer bump stencil. And as you can see here, the apertures here are extremely small, literally hundreds of thousands, 342,000 actually apertures here. This sample actually has 3 mil or 75 micron diameter apertures. What I'm going to do now is we're going to go ahead and perform an inspection. And you'll see here on the screen that we have over 15 different inspection algorithms that you can use. So I'll simply pick one of the 15 here to perform an inspection of this wafer bump stencil. In the lower left corner, you'll see that there's a counter actually counting down. So it's literally comparing the CAD or the Gerber data for every aperture on this 342,000 aperture stencil. It's comparing each Gerber data image against the actual stencil itself. And in a few minutes, we'll actually show you the process of scanning the stencils, etc. But I wanted to start this way. Now, the way the system is set up is that you scan the stencil, you import the data, you overlay, and you inspect. Now, on the screen in front of you, again, it's processing down. We're down all the way down to now 50,000 apertures left as it counts down. Now, this is an extreme example, obviously, this large number of apertures. And in fact, I'll zoom out real quickly just so you can see what the stencil looks like. And you can see that at the bottom of the screen, there are 276 errors on this stencil. And you can see they're pretty uniform over the entire stencil surface, okay? The way the system works is it numbers the errors. So this is the first error. There's the second error, number 3, number 4, number 5. I can also go backwards, previous, back to error number 1. I can get in very close, turn off the CAD data, and we can see real quickly that we have a completely blocked aperture here. If I hit N for next, as you see at the bottom of the screen, N for next, we move to error number 2. And you can see with error number 2, there's just a little bit of light coming through that aperture. Error number 3, 4, 5, 6, etc., etc. Okay? Now, I want to share with you, this is a good stencil. This stencil is a good stencil, but this stencil was cleaned poorly. These apertures are blocked with solder paste. That's why you see some light coming through the apertures. So this is a good example of one use of the ScanSTENCIL system is to inspect stencils after cleaning. So yes, you can use this for inbound stencil inspection, but also for post-cleaning inspection. So I started with this stencil just to give you an idea of what the system does, and I picked a pretty extreme example with the 340,000 apertures and extremely small apertures. In most cases, your stencils have far fewer apertures than that. Since we had that sample screen in the PowerPoint, let me show you the sample printed solder paste. Let me go ahead and bring up that image right now. Okay, and looking at this, it's all, very similar to the stencil in that we have CAD data, we have the area of the board we're interested in, which in this case is the solder paste, okay? So the way our system works, like you saw with the stencil, we can backlight it for a stencil to make sure all the aperture openings are clear. But when you're inspecting something like solder paste or glue or the actual solder mask on a board or maybe drill holes, you could light the board from the front. So we use both transmissive or reflective light. That means light from the front or light from the back. Well, in this case, this board obviously has a problem. And so what we'll do here is instead of using the inspection, again, these are the 15 different inspection functions, right? In this case, I'm going to do an area inspection. So a 2D area inspection. And so we could look for apertures that have, let's say, less than, let's pick 50% or 60% solder paste. Apertures less than 60%, and flag any apertures or solder paste deposits that have more than 125%. Because the board is so bad, I'm just going to inspect in the window so you can see what that looks like. So you can see instantly we have these apertures, or these deposits that are less than 50% and these deposits that are more than 50%. Okay? Now again, we can look at that with the CAD data if we wish. This is the CAD data for the stencil file. We color separate on the paste, which is what we're interested in, and it has performed the inspection. All right, let's go back to the PowerPoint now. And you can see that we dove into the two samples we have on this slide. Not only will it work for inspecting traditional solder paste stencils, emulsion screens, But really, we can inspect films, photo tools, glass, diazo, you name it. There are, anything that you're working on that can be in this type of a format can be inspected here. So here's an optical encoder, and these defects are 25 micron or a mil. A protrusion on the right, some blockage here on the left. Let me move to the next example. Film or photo tool inspection. If you're making emulsion screens, then of course you will need to have a photo tool in order to image that mesh screen. So this system will pick out pinholes, mouse bites, and protrusions. Again, let us go to the software itself to go ahead and take a look at what that might look like. I've got a couple examples here for you in the film area. I'll come up first with a sample that is in the PowerPoint presentation. We'll open that one up. And in this case, we just scan the film in monochrome. I'm going to draw a window around the part of the film that we care about. We don't really care about the border. And in this case, I'll use yet another function. I'm going to look at something called micro defect check shorts and opens. We'll go ahead and run this function, and you will see here that it's targeted to find the pinholes and mouse bites and any kind of photo tool type damage. Just like on a stencil, they're numbered from 1, in this case, to 73. In fact, let me run this inspection one more time very quickly because I failed to check inside window. So there we inspect inside window. You can see a lot of the errors were along the outside here. So now we actually only have 13 errors that we really care about. So again, only inspect the areas that make sense. I should point out that we also have an advanced mask function. So we can mask away certain areas if you don't want to inspect, for example, in a stencil, if there's an area that you don't care about. But for most customers, they'll inspect the entire emulsion screen or the stencil. So again, in this case, we can get in close if we want, just zooming in quickly. I'm using my mouse to zoom in, or I can use Control plus or minus. And you can simply single step through the errors at whatever zoom level you want. So you can see here that we have a situation where the track is actually narrowed. Here we have a protrusion. Here we have a mouse bite. And we use red, the color red, to highlight these errors to help make them more visible. I can turn that off if you'd like so you can see the pinhole here. Here's the very small little pinhole, and you can see the red that's helping the operator identify that there really is a serious problem here. So here's a scratch in this area. Here we can have some sort of a mouse bite kind of a thing. Here we have a protrusion or potential short. Again, looks like another scratch. I can turn this on and off. Another scratch over 2 tracks here. Another protrusion. Okay, so I'm going to quit out of this film sample and bring up yet another sample that I think you might enjoy. We'll perform this inspection. I'm opening this this film right now. This is a traditional circuit board, and this could actually be a board itself, so it doesn't have to be a film. So in this case, we have the image of the film. Instead of scanning this one in monochrome, this was actually filmed or scanned in color. So we can see the black image. We use a color separation process to extract the film. Here we have the CAD data over the top. The CAD data in this system is really a green color. If I get in a little bit closer here, you can see the green CAD data. And we have, of course, the monochrome image or the color image there with it is the black film there. So what we do is we simply overlay the CAD data on top of the film and perform the inspection. In this case, we'll go ahead and do that. Actually, we'll do a couple of different inspections. First, let's go ahead and run a different inspection, which is called Gerber Comparison Check, which is actually the same function as this icon over on the left. You can run the software with icons or menus if you wish, or even hotkeys if you wish. In this case, we're going to go ahead and perform an inspection over the board, and we're inspecting anywhere from 2 mil apertures and larger, 2 mil and larger. And you'll notice that I did, again, inspect in a window here, but let's go ahead and not inspect in a window. Let's go ahead and inspect the entire board. So I'll repeat that because there were no errors in this window, But if I go ahead and inspect the entire board, so you'll see I did not check this time, that this film does have some errors on it, and I want to check those. I'm checking for 2 mils or 50 micron or larger, and then you're going to see we will run a separate function that will check for scratches and mouse bites and pinholes that are much smaller than the 2 mil. So if I get in close here, let's turn off the CAD data, we can see that we have areas that are a problem. So again, it's very obvious that we have some sort of defect in the film here. Here we have a rather large pinhole, if you will. In fact, we can even measure that. If we get in close, I have measurement capability, point to point. I'll go ahead and measure from here to here. And you can see at the bottom of the screen that is a 10 mil hole, 10 mil, I wouldn't call that a pinhole. It's a large hole in this film here that is not part of the CAD data. So it was not part of the CAD data, so it's been flagged as an error. There's even a larger one there. Again, since I did not draw a window around, it also picked out some errors that are off the board itself. Okay, so let me go ahead and draw a window just around the board itself here, or the film itself. We did a Gerber comparison check. Let's also run that same inspection for mouse bites and pinholes, shorts, and opens for anything that's 2 mil or smaller. And here it found 12 errors. If we get in close, again, I'm using that red color to help you see the error. Hit to the next one. We see we have a pinhole here. I can turn off the CAD data, and we can turn off the red if you want. And you can see this is a very large pinhole that's in this track. Here is some contamination. Here we have, again, I'm going to put the green CAD data on so you can see this is a pinhole. Here we have something that's even violated the 2 mil rule as far as alignment issues. Okay, here's a very small pinhole, very small pinhole. If I measure this small pinhole again, let's see what size this one is. This pinhole from here to here is 0.4 mils. 0.4 mils, approximately 12 to 15 micron. So you can see that we find very small defects in the film. You can, again, you can ignore these defects if you want or do a repair. It's whatever's appropriate for your facility. Okay, let me quit out of this film and go back to the PowerPoint presentation. And you can see that we covered this film inspection in great detail. Emulsion screens. We do inspect emulsion screens. We are the leading system in the world for solder paste stencils and for emulsion screens. That's because we have this flexibility of front lighting, back lighting, the ability to image in color, monochrome, or gray. So you can see here on this emulsion screen that we have some contamination on the left. We also have a pinhole in the emulsion on the right. Something didn't wash out here, and yet we have a problem over here. So let me go ahead now and let's do a real quick inspection of a real emulsion screen here. So let me con up with one of these sample images. This particular screen is out of the automotive industry. If I open this up, and we'll go ahead and perform, I'll draw the window again. Let's just inspect in the area that we want to inspect. Perform the inspection. This particular sample has tracks that are the tracks are less than 3 mils, approximately, I think 60 micron in size. And if we take a look at the various errors that this automatically found, you will see that we actually have a pinhole. I'll go ahead and turn off the CAD data so you can see that, a pinhole in between the tracks right in here, okay? Okay, and that's error number 1. Number 2, we have some contamination. Again, I can turn off the CAD data. You can see that the track has actually been blocked with this contamination. Here's another bit of a pinhole in the emulsion area. Here we have a defect and yet another defect and some more contamination or debris that's on this. So we can see here this type of inspection does an amazing job of finding errors on your emulsion screens, your stencils, and your photo tools. Let's now go back to the PowerPoint presentation. And we have yet another example of using this system for inbound bare PCB inspection. If someone wanted to inspect inner layers, they could certainly do that. Here's some damage in an inner layer. So this, again, the ScanSTENCIL system is multi-purpose. Yes, it does stencils, but it does so much more. As long as we're here on a board, let's take a look at a board. I'm going to look at a PCB that was inbound. And this particular one, you will notice, has some stretch to it, which is a very common error that's out there. And obviously that can make a huge difference with your screen printing of solder paste. So I'm going to go ahead and inspect this again. And just like before, I can toggle the CAD data on and off, the color image on and off, and we have the scanned image as well, okay, of the parts. So essentially, you'll see on here we have some errors. On the left-hand side, the fiducials lined up pretty well. We flagged the fiducial as an error because it's thinking that it's supposed to be there. But if I look at the right-hand side, you'll see that we do have an alignment error. So there is some stretch here. So from the standpoint of actually printing solder paste on this board, that could be a serious problem. You're going to have paste on the fine pitch devices that could have a problem. Okay, you can see the alignment here. So we have over 5 mils of shift, over a 250 micron of shift. Okay, now there's also another error here that I'd like to point out. I'm going to toggle the CAD data on and off. And so you can see here that we have a very serious problem. We have 2 pads on this BGA that will not get soldered because the solder mask is covering the pad. This is a very serious error. So not only do we have an alignment error on this board, but we also are missing some openings in the solder mask. I'm going to come back to this stencil in a minute because, or back to this board in a minute, because I'm going to show you a very powerful capability of the ScanSTENCIL system, because we can actually alter that stencil data to better match the board with dramatic benefits. Right now, let's step through some more images for you. We do handle partial or step etch inspection. You can see we have the full area etched away, but we also have a step etch feature here that can be inspected. The system is able to scan and image 3-dimensional parts, populated boards. Here we have a component with wire bonds, so we have a die attached situation, populated board again, and components. So you can, obviously inspect leads and balls and all kinds of things, wire bond connections. It's a multi-purpose system. Just thought I'd give you some images of that. That is the measurement versus inspection, or discussion of measurement inspection. Let's talk about the technology itself. This is what the system looks like. It's using a flatbed scanner that's been modified to work in this application, running on this desk. It is a calibrated device, NIST certified calibrated device with a certificate of conformity. You can see we have a stencil located on top of the scanner. The scanner is below the desk here. The glass calibration plate that comes with the system is stored on a shelf below the scanner. You can see we have a light box on an arm. This is giving you that transmissive light, that top light that passes down through the stencils, through the apertures in the stencil, through the openings and the drill holes in a PCB, or through the mesh on an emulsion screen. You can see the stencil on the screen. You provide your own PCB, or your own PC. Obviously, we could provide one if that's of interest to you. This is a contact system where the part actually sits on the glass of the scanner. So the scanner faces up, the part faces down. So those parts that you saw with solder paste or the wet epoxy, either dispensed or printed, those can be imaged with a standoff of some sort, because again, the part is facing down. There is no limit to part size. The scanner itself is A3 size. However, if the stencil or the part is larger than that, then you simply take more than one image. We have customers, for example, Kodak today inspects all of their electronic film on the ScanCAD system. On a system, they are actually inspecting approximately 108 inches by 36 inches, simply taking more than one image. We have some customers with very large stencils that are inspecting not in the electronics business, in the automotive business. We have other customers still that are inspecting parts that are 4 and 5 meters long on this system. This is why we keep it an open architected system. So there really is no limit to part size. It simply means you take more than one image and do that inspection that we've been showing you. The lighting can be top or bottom, either reflective or transmissive. I mentioned already this is a NIST certified system. It does come with this NIST certified glass calibration plate, which obviously supports your ISO certification. The programming and the inspection can be done against CAD data, which of course would be Gerber or maybe DXF data, as well as golden parts. We are able to inspect at very high resolutions for parts all the way down into 1 mil or 25 micron. I've already showed you images of errors smaller than 25 micron. We do have customers today going to even smaller application areas. For example, the masks that are used in cell phones and that type of technology. This is your way to guarantee stencil and screen accuracy and to make sure everything's okay before you go into production. Again, these are the tools that are about to make large numbers of boards for you. Let's make sure the tool is in good shape before you take it into production. Let me show you the quick and easy steps involved in inspecting a stencil or a screen or, again, a film or any of these things we've been talking about. The process is exactly the same. You import the Gerber file or the CAD data. If you're using a golden board, you will have imaged that golden board earlier. You scan the part that wants to be inspected. You overlay the scan image with either the CAD data or that golden part, perform the inspection automatically, review any errors like you saw me doing, and finally print a report. So these are the steps. Importing the Gerber data. I've already shared with you that it's green in color, green for Gerber, green for CAD data. That data, again, could be DXF if you're not using Gerber data. Second step is to scan, either using that top or bottom light, either in monochrome or color or gray, based on what you want to do. You can see here that whatever we do, we end up getting to a blue image. So if you do scan in color, we will still do a color extraction to bring you to a monochrome image, which is this blue image. And we'll go ahead and show you a short video now of actually scanning a stencil. So that is running right now, so you can see that. We then move into the overlay, where we overlay the scan image on the Gerber, or vice versa, overlay the CAD or Gerber data on the scan image. And the software, as I will show you in a second, will automatically overlay, flip, and rotate and align the software on there. And of course, any skew between the image and the Gerber can be eliminated, any skew or rotation. You perform the inspection. I've already shared with you 4 or 5 different inspection methods, algorithms out of the 15 we have so far in this short presentation. So you know there's a lot of capability there, and there's not enough time to go through the details of each one of these things. Just want to give you a high-level overview of how this is done. The errors are flagged for the operator to move through to, if there are any errors, and ideally there are not any errors, right? If there are errors, possibly the emulsion screen or stencil can be cleaned and then re-inspected. Hopefully it can be salvaged. The part does not need to be destroyed. In this case, you would then, you could print a report. This can also be an electronic paperless document if you wish. And there is an SPC log file as well, maintaining data for your quality control department. In the case of stencil manufacturers, they like to include a certificate to ship with the stencil showing that it has been inspected. This can be signed by the operator, a date and timestamp, all of the relevant information on that certificate. We do have a variety of ways, again, to inspect things. Again, like we've been talking about, comparing the stencil to the Gerber or the golden part. Let me go ahead and run a couple more examples right now, now that you've seen that 6-step method. I'll go ahead and quit out of this example here, and we'll move to the stencil and open this job up. Now, what we shared with you a second ago is the first step is to import the Gerber data, which is green. The second step is to scan the stencil. In this case, I scan monochrome, so the image will come in as blue. In fact, I'll zoom in on this just so you can see that we do have even some errors in this BGA that you can see even with your eye right now. Okay, so here you have the CAD data, you have the image information, and let's now just go ahead and move down through these icons, because that's typically what an operator does. A typical stencil inspection, complete from when you walk up to the system until you print the document or store the electronic data, is 5 minutes. The total process is 5 minutes. So the first icon the operator will normally use is the automatic overlay, which will actually flip and rotate the Gerber data to match the stencil. So that's that automatic alignment function I was talking about. And then we can go ahead and perform the inspection. Again, I'll use the Gerber comparison check. We'll perform an inspection. In this case, the system has detected a total of 57 errors. And I can zoom in close to the first error and then error number 2, and you can see right away that we have a serious problem. This is actually a manufacturing defect here. These are apertures that were being laser cut, and you can even see the laser did a partial cut, and for whatever reason, the laser did not finish the cut and the aperture did not drop. So here we have a situation where the Gerber data is asking for an aperture and the aperture is not present in the stencil. The next errors have to do with an alignment situation. Here we have the Gerber and the apertures are perfectly aligned, and these are not. We actually see some opening without Gerber and some Gerber without an opening. So this is a typical situation that you will see if you have an incorrect version of Gerber data, maybe Rev A Gerber data or Rev A stencil that's going to be placed on a Rev B board. For some reason, there was an engineering change. They moved some components over, and that is a serious error where everything's lined up beautifully, and yet there's a problem here. Obviously, an operator, by looking at the stencil, will not catch this error. Even if you lay the stencil on top of a PCB, you're manually checking it. You're not going to catch that error. I'll skip forward now to see if it catches the errors in the BGA, and yes, it did. I'll zoom in a little bit. So you can see here we have an aperture here that is either completely blocked, and here's a partially blocked one, or there's some other contamination issue or some other kind of problem. Okay, so again, we have more errors here. This looks like another alignment situation, et cetera, et cetera. So those are the types of errors that you will see with stencil inspection. Let me go back to the PowerPoint presentation. Another thing you can do is compare a board to the Gerber data to a part, and not just a stencil, but a board. And of course, you saw me do this for the PCB a few minutes ago. So that's a good example of that. Look at this. Some of you may ask, can I compare a board to a stencil with no CAD data? Is that possible? The answer is yes. I will go ahead and share an image here. Here we have a PCB compared to a stencil. And all we do here is we scan the stencil on layer 1. We've scanned the solder paste stencil on layer 2. So let's go ahead and take a look at that. So layer 1 has the PCB. Here's the bare board. Layer 2 has the stencil. I'll go ahead and turn off layer 1 so you can see that. Okay, so here's the stencil in red. Okay, I'll zoom out. There is the board in color. We color separate. Let's take away the color image now. And even with your human eye, you can see that we have some interesting stuff here that probably is going to flag as an error. Everything in the pink is where the blue and the red overlay, where there's a bright red, means that we have a problem. Well, another one of our inspection capabilities is to what we call raster to raster check. That's check one image against another and show anything where there's an error. So again, I'll toggle this red off so you can see we have 1, 2, 3, 4, 5 errors. 1 of 5. So let's go to the errors. Let's get in close, see what that looks like. Error number 1, I can turn on the stencil layer 2, overlaying, so you can see here that I have 2 apertures here that are on the stencil that are not on the board. Also, we flagged 3 errors here, and if I turn the board back on again, those are fiducials in the corner, so more than likely they don't want to put solder paste on those fiducials, okay? But here's an example of comparing a board to a stencil with no CAD data. We do have the ability with ScanSTENCIL to create Gerber data when Gerber data is not there. So we could scan a board and actually make CAD data. Given the short nature of this presentation, I don't want to take you through that, but just know that it's very fast and very automatic. Probably one of the biggest benefits and reasons to move forward with the ScanSTENCIL system is a solid, concrete, proven benefit of a 43% reduction in solder paste defects. This is a published study by Motorola. They did a 3-week study running 125,000 units through their production process. It was published in the April 2006 issue of SMT magazine. And essentially, the process is where if you adjust your CAD data, your stencil data, to match the board before you make your stencil, so the stencil exactly matches the board, you will have a much tighter grouping, a much better placement of solder paste on pad. So the moral of the story is do not make the stencil until your boards come in. When your boards come in, use the ScanSTENCIL system and adjust the stencil data to match the board. Now let me go ahead and give you that example now that we just saw a second ago of that PCB that had some stretch. Okay, so if I come up to that board, we'll open that up. You already know we have these errors, right? From our previous inspection. You know that we have an alignment problem here on this board. So what we're going to do, in fact, I'm going to still getting close here so you can see this. I'm going to come up to the top here and use our automatic Gerber rubber overlap. If I push that button, you'll see here, boom, automatically, you'll see the Gerber data has been shifted to match the board. Very important for fine pitch devices. Very important for lead-free environment. That we make a slight change here. Remember, this board had a 5 mil shift. Now the fact is that, yeah, you might be able to get away with a 5 mil shift in some large pad type environments. But with the smaller and smaller devices, you will start creating solder paste defects that can be very expensive. Let me run that inspection again that you saw me run a minute ago. Run the very same inspection, and instead of having a whole bunch of errors, I just have a few. Yes, I still have this very serious error we talked about, right? The very serious error of solder mask, of the solder mask missing a couple of openings here for this BGA. Very, very bad, right? But assuming those weren't there, we have some false errors around the fiducial here and some false errors around the fiducial over here. So the bottom line is you don't see any alignment problems at all on this board over here. The automatic Gerber rubber overlap fixed that problem. That is how you can achieve a 43% reduction in solder paste defects. So there you have it. This has been a quick presentation on the ScanSTENCIL system. Yes, we've been around over 30 years. We're in 50 countries with over 1,000 installed customers running this technology, many of them with large numbers of systems. Yes, a single system can check your tooling, your pallets, your fixtures, your trays. We are able to look at your components. Multiple vendors, you can compare those in multiple layers, if you will, up to 99 layers to be overlaid. You can check their shape, their color, their size. Yes, you can use this for inbound bare board inspection. We don't care what kind of board you're using. Yes, we are able to inspect first piece of your paste and printed adhesive type inspections. We can inspect coatings. Obviously, you saw me check the solder mask a minute ago, but we can also check drill holes. We can check legend and silkscreen. Clearly, ScanSTENCIL, its primary focus are stencil and screens, checking for stretch, missing blocked or damaged apertures, in the case of emulsion screens, pinholes, mouse bites, etc. The system is able, if you want, optionally to create assembly programs and to do a variety of other things as well. It's truly a multi-purpose system. So why ScanCAD systems? First off, because they're proven. There are customers around the world benefiting from these systems. They are economical, low cost, and easy to use, very fast ROI. Just that one benefit that I shared with you, a 43% reduction in solder paste defects, is extremely significant. Easy to use, PC-based system, small footprint. It is an offline system, so a single system supports multiple lines. It is calibrated using the NIST calibration plate. Many inputs, many outputs. It is giving you the traceability that's mandatory for automotive, medical, and aerospace type applications. These images can be stored for compliance programs. Literally, the images of the stencil, screen, and board, plus all of the inspection results, are stored forever. Multi-purpose, measurement, inspection, and data creation. Yes, features down to 1 mil, 25 micron, some customers going smaller. Annual software upgrades and support for the last 30 years. So the whole objective here is to eliminate surprises in your production environment. It's been a pleasure presenting to you today. Please let us know how we can be of further assistance.